Hi, this video is the last video on the probability distribution series. In this series, we're going to talk about converting values to z-scores and calculating probability based on them, and then also calculating values based on percentiles. So, if you remember in our 8B notes, we originally talked about z-scores for the normal distribution, and we were labeling our normal distribution curves with the values 0, 1, 2, and 3 on the left or on the right hand side, and -1, -2, and -3 on the right hand side. Okay, so that was for our standard normal distribution. The difference when we change to the normal distribution curve is that instead of the middle value, the middle point in our curve being 0, the middle point in our bell-shaped curve is going to be the mean for our distribution. Our sample mean tends to be, and instead of, as we move to the right, going up by 1, 2, or 3, we're going to go up by 1 standard deviation, 2 standard deviations, and 3 standard deviations. As we move to the left, we go down 1 standard deviation, 2 standard deviations, and 3 standard deviations. Okay, so any normal distribution can be converted to the standard normal distribution by taking the value we're interested in, subtracting the sample mean from it, and dividing by the standard deviation. Okay, and so we're going to be able to calculate probabilities for values for normal distributions by doing this transition. So if I have data that is normally distributed and has a mean of 12 and a standard deviation of 1.5, I could figure out the corresponding z-score of a value of 15.75, right? We know that if our mean is 12, a value of 15.75 would be over on the right-hand side. Exactly how far over? We would use our formula, right? So z is equal to x minus mu over sigma. So the value we're converting is 15.75, our mean is 12, and our standard deviation is 1.5. Putting that into our calculator, we make sure we put the 15.75 minus 12 inside of a bracket, do the subtraction first, then divide by 1.5, it comes out to 2.5. So what that tells us is that if we're calculating probabilities based on a value of 15.75 for that particular distribution, it would just be like if we were calculating probabilities for a z-score of 2.5. And we know how to look those up. If we have an x-score of 11.25, again, because our mean is 12, we can anticipate a negative value here to figure out exactly what the corresponding z-score is for a value of 11.25. We plug it into the formula. Z is equal to x, which is 11.25 in this case, minus the mean, which is 12, divided by standard deviation, which is 1.5. Putting that into our calculator and dividing out, it comes out to negative 0.5. So an x value of 11.25 is the same as a z value of negative 0.5. Okay, so now that we've done two examples together, pause the video and try out the last example here. So an x value of 7.5 comes out to a z value of -3, given the mean and standard deviation that we were given. And an x value of 12.5 comes out to a Z value of 0.33 given the information we're given. When we're calculating Z values, we're going to be rounding to 2 decimal places because that's the accuracy that we're going to be able to look them up in our table. Okay, so now that we know how to calculate Z scores, let's look at a problem. Okay, so we're going to be able to use our Z scores to find probabilities associated with a problem. The key things is to take the values we're given and transform it into a Z score. Draw a little picture to make sure we know what the probability is that we're finding, and then answer the question. So let's look at our examples here. The heights of young women are approximately normal with a mean of 64.5 inches and a standard deviation of 2.5 inches. What's the probability that a randomly selected woman measures less than 6.5 inches? So maybe actually I'll start off with drawing the picture. So it's normally distributed. It has a mean of 64.5, and then the value that I'm interested in is 61.5, and I'm interested in what the probability is that we're lower than 61.5. Okay, so how do I do this? I take my X value and I convert it to a Z score. Z is equal to X minus mean over standard deviation. So an X value of 61.5 corresponds to a Z value of negative 1.20. So I'm figuring out the probability that I have a Z value of less than negative 1.20. Okay, I can write a statement about this. I can say, so the probability that X is less than or equal to 61.5 is equal to the probability that Z is less than or equal to negative 1.20. Okay, and so to answer this question, now I go to my table. I know how to find the probability that something is less than negative 1.20. I look it up in the table, negative 1.20. And because it's a less than question, I can read it directly from the chart. So my answer to this question is 0.1151. And I can write a concluding sentence. So, therefore, the probability that a randomly selected woman measures less than 61.5 inches tall is 0.1151. Awesome. Next question. What's the probability that a randomly selected woman measures between 60 and 68 inches tall? Okay, again, what am I finding here? I'm finding a between area. I know my mean height is still 64.5, but now I have two values to consider. I'm finding the probability that I'm between 60 and 68. Okay, so I'm trying to find the area between those two values. So similar process before, only now I have two different Z values to convert. I have to convert my 60. Okay, so I do 60 minus mean divided by standard deviation and calculate what that is. And then I also have to figure out what the Z score associated with 68 is. 68 minus 64.5 over 2.5. And I'll put those into my calculator. So those Z scores come out to negative 1.8 and positive 1.4 respectively. The next thing we're going to do is look those values up in our chart. So a Z score of negative 1.8 corresponds with a probability of 0.0359. A Z score of positive 1.4 corresponds with a probability of 0.9192. Okay, so I've written down those values on our chart. So the next thing we need to do is figure out the probability that we're between 60 and 68 inches tall. So because this is between, we're going to figure out the difference between those two values. So we're going to take 0.9192 and subtract 0.0349. Okay, when we do that subtraction, it comes out to 0.8833. And so we can write a therefore statement summarizing our results. Therefore, the probability that a randomly selected woman is between 60 and 68 inches tall is 0.8833. Okay, last question that we have to do here, we've got what's the probability that a randomly selected woman is more than 67.3 inches tall. The first thing we've got to do is draw our picture. In the middle of the bell curve, I put our mean, and then to the right, because it's larger, I put 67.6 inches. The next thing I'm going to do is convert that 67.6 into a z-score. So I can take my x value and convert it into an equivalent z-score. So I take my x value, I subtract the mean, and divide by the standard deviation. Putting that into our calculator, we end up getting a z value of 1.24 when we round to 2 decimal places. Okay. Our next step will be to look up the value in our table. So I look up 1.24, which comes out to 0.825. Now I want you to remember that the value on that table that we look up is the value to the left, the value less than a particular z-score. So if we're looking for the probability that x is greater than 67.6, we're looking for the probability that z is greater than 1.24. Then for a greater than question, we're going to take the probability that we look up in the chart and subtract it from 1 to find the complement. So our answer is 0.1075. To finish the question, I write my therefore statement. Therefore, the probability that a randomly selected woman is more than 67.6 inches tall is I wrote down the wrong value there, is 0.1075. Always make sure that your answer makes sense. That corresponds, my correct answer corresponds to about 10% chance, whereas my incorrect answer is closer to 90% chance. Okay, and then our last question we're looking at are going to be working backwards. So when we're given a percent or a probability and we're asked to work backwards. So we're given an average, a standard deviation, and we want to know how long the shortest percent of pregnancies are. Okay, how do we do this? So the first thing we need to do is draw our picture of our curve. We know what our mean value is, right? We know our standard deviation, and what we're trying to figure out is what our shortest 10% are. 10% correspond with a probability of 0.1000. So we want to figure out what the x value is associated with this cutoff value. In order to do that, first we have to figure out what the z-score associated with a cutoff of 0.1 is. Okay, to figure that out, we're going to go to our table and look for where we see a value closest to 0.1. Okay, and we're going to do some scouring and we're going to figure out where the closest value is, and I see, oh, 0.1003 occurs at a z value of negative 1.28. Okay, so that cutoff value corresponds with a z value of negative 1.28. Once I have my z value, to figure out my corresponding x value, I substitute in the formula mean plus z times standard deviation. Calculating that out, I get my conclusion. Therefore, the shortest 10% of pregnancies are less than 245 days long. If I want to know how long the longest 10% of the pregnancies are, because I'm still finding that same probability, I would convert my z-score to a positive value. Well, we can write our conclusion. If you have questions, please stop into WebEx. There's homework questions that aren't in this note that are included as an attachment on D2L. Okay, we'll talk soon and take care of yourselves. Bye.